Welcome to Vending University, the ultimate guide to becoming a vending operator. In this course, we will explore how machine learning can revolutionize your vending business by predicting product demand accurately. Understanding customer preferences, seasonal trends, and location specific behaviors allows you to stock the right products at the right time, minimizing waste and maximizing profits. Predicting demand no longer has to rely on guesswork or simple historical sales. Machine learning analyzes complex patterns in your data, from past purchases to foot traffic, and even external factors like weather or local events. This enables you to make smarter, data driven decisions that improve inventory management and customer satisfaction. We will begin with an overview of machine learning fundamentals, explaining key concepts, algorithms, and types of data used for predictive modeling. You don't need to be a coding expert. Our step-by-step approach ensures practical application for vending operations. Next, we'll dive into data collection and preparation. You'll learn how to organize sales records, clean data sets, and integrate external information to improve model accuracy. Proper data handling is crucial for reliable predictions and long-term success. Afterward, you'll build and train predictive models designed specifically for vending machines. You'll see how to forecast demand for individual products, optimize stock levels, and identify trends that can inform new product choices. Hands-on exercises make these concepts actionable and directly applicable. Finally, we'll cover monitoring model performance and refining predictions over time. Demand prediction is an ongoing process, and machine learning helps you adapt quickly to changing customer behavior. By the end of this course, you'll have the skills and tools to make your vending business smarter, more efficient, and highly profitable. Module 1, Introduction to Machine Learning in Vending Operations. In this module, we will introduce the concept of machine learning and its role in modern vending operations. Machine learning is a branch of artificial intelligence that allows systems to learn from data, identify patterns, and make predictions without explicit programming. For vending operators, this means using sales data and other relevant information to anticipate product demand and optimize inventory. Vending businesses traditionally relied on intuition and manual tracking to manage stock. While this can work in simple scenarios, it often leads to overstocking or running out of popular items. Machine learning provides a more accurate, data-driven alternative, helping operators make informed decisions that reduce waste and boost revenue. Understanding customer behavior is central to predicting demand. Machine learning models can analyze past purchase patterns, seasonal trends, and location-specific factors to determine which products are likely to sell and when. By recognizing trends early, operators can adjust stock and promotions to meet actual demand. Another key benefit is efficiency. Instead of manually monitoring sales and adjusting inventory, machine learning models can automate much of this process. Predictive algorithms continuously learn from new data, improving their accuracy over time and allowing operators to focus on growth strategies rather than day-to-day stock problems. In this module, you will also learn the basics of different types of machine learning, including supervised and unsupervised learning, and how these approaches apply to vending operations. Examples of demand forecasting, product recommendations, and trend analysis provide a practical understanding of how the technology works. By the end of this module, you will see how machine learning transforms vending operations from reactive management to proactive decision-making. This foundation will prepare you for later modules, where you will dive deeper into data preparation, model building, and applying predictive insights to optimize your vending business. Module 2, Understanding Product Demand, Patterns and Influencing Factors. In this module, we will explore the concept of product demand and the factors that influence it in vending operations. Understanding demand is essential for stocking the right items, maximizing sales, and minimizing waste. By analyzing patterns in customer behavior, operators can identify which products are popular, which are seasonal, and how demand changes over time. Product demand is influenced by multiple factors. Seasonality plays a major role, as certain products sell more during specific times of the year. Location is another key factor, as foot traffic, nearby businesses, and customer demographics all affect which items are likely to be purchased. Recognizing these patterns is critical for effective inventory management. Consumer behavior also drives demand. Preferences, purchasing habits, and responses to promotions all shape what products sell. By studying historical sales data, operators can uncover trends and anticipate which items will perform best in their machines. This allows for smarter, data-driven stocking decisions. External factors must also be considered. Weather, local events, holidays, and even economic conditions can impact sales. Machine learning models can incorporate these variables to improve predictions, ensuring that inventory aligns closely with real-world demand rather than assumptions or guesswork. In this module, you will learn how to identify patterns in sales data and analyze the factors influencing demand. Techniques such as trend analysis, correlation evaluation, and demand segmentation will be introduced to provide a practical foundation for forecasting. By the end of this module, you will understand how product demand is shaped and how insights from these patterns can improve vending operations. This knowledge will serve as a basis for building predictive models in later modules, ensuring your inventory matches actual customer needs. Module 3. Data collection and preparation for accurate predictions. In this module, we will cover the essential steps for collecting and preparing data for machine learning models in vending operations. Accurate predictions depend on high-quality data, and understanding how to gather, clean, and organize your sales and operational information is critical for success. The first step is identifying relevant data sources. This includes historical sales records, product inventory logs, machine usage data, and even customer interaction metrics. The more comprehensive the data, the better the predictive models can understand patterns and make reliable forecasts. Data cleaning is equally important. Real-world data often contains errors, missing values, or inconsistencies that can negatively impact model accuracy. This module will guide you through removing duplicates, correcting errors, and handling missing entries to ensure your dataset is reliable and ready for analysis. Next, we will discuss data transformation. Raw data often needs to be structured in a format that machine learning algorithms can process. This includes converting dates into meaningful features, normalizing numerical values, and categorizing product types. Proper preparation ensures that models interpret the information correctly and make precise predictions. We will also explore the integration of external data sources, such as weather patterns, local events, or seasonal trends. Including these variables can significantly improve demand predictions by accounting for factors outside of direct sales history. Techniques for combining and aligning multiple datasets will be covered in detail. By the end of this module, you will understand how to collect, clean, and prepare data for machine learning in vending operations. Proper data preparation is the foundation for building accurate predictive models, and mastering this step will set you up for success in the upcoming modules focused on analysis and forecasting. Module 4, Exploratory Data Analysis for Vending Sales Data. In this module, we will focus on exploratory data analysis, EDA, and how it helps vending operators understand sales patterns before building predictive models. EDA is the process of examining, visualizing, and summarizing data to uncover trends, anomalies, and relationships that can inform better decision-making. The first step in EDA is summarizing your data. By calculating key statistics such as totals, averages, and frequency counts, you can gain a clear understanding of overall sales performance. This step helps identify top-selling products, low-performing items, and periods of high or low demand. Visualization plays a crucial role in EDA. Charts, graphs, and heat maps allow you to see patterns that are not immediately obvious in raw numbers. For example, line charts can show seasonal trends, while bar graphs can compare product performance across different locations. Visual analysis makes it easier to spot opportunities and potential problems. Detecting anomalies is another important aspect. Outliers in sales data, such as sudden spikes or drops, can affect machine learning models if not addressed. This module will teach methods for identifying and handling unusual data points, ensuring that your predictions remain accurate and reliable. Exploring relationships between variables is also essential. By examining how factors like day of the week, time of day, or external events influence product demand, you can uncover correlations that will improve forecasting accuracy. Understanding these connections sets the stage for effective predictive modeling. By the end of this module, you will be able to analyze and interpret vending sales data effectively. EDA provides the insights necessary to make informed decisions, refine your data set, and prepare for the next steps in machine learning, ensuring your models are based on a solid understanding of customer behavior and trends. Module 5, Supervised Learning Models for Demand Forecasting. In this module, we will explore supervised learning and how it can be applied to predict product demand in vending operations. Supervised learning uses labeled data, meaning past sales and demand outcomes, to train models to forecast future sales accurately. The process begins with selecting the right features, which are variables that influence demand. These can include historical sales, product categories, time of day of the week, and external factors such as weather or local events. Proper feature selection is essential for creating models that capture real-world patterns. Next, we will discuss common supervised learning algorithms used for demand forecasting. Linear regression, decision trees, and ensemble methods like random forests are often applied in vending data analysis. Each algorithm has its strengths, and we will cover how to choose the most suitable approach for your dataset. Training the model involves feeding it historical data so it can learn relationships between features and sales outcomes. The model adjusts its parameters to minimize errors and improve prediction accuracy. We will also cover techniques such as cross-validation to ensure the model generalizes well to unseen data. Evaluating model performance is crucial. Metrics like mean absolute error, root mean squared error, and R-squared help measure how well predictions match actual sales. Understanding these metrics allows operators to select the most reliable model for their vending operations. By the end of this module, you will have a solid understanding of supervised learning and how to implement models that predict product demand. These techniques allow vending operators to make proactive decisions, optimize inventory, and increase profitability by anticipating customer needs rather than reacting to sales after the fact. Module 6, Unsupervised Learning and Clustering for Product Insights. In this module, we will explore unsupervised learning and how it can provide valuable insights for vending operations. Unlike supervised learning, unsupervised learning does not rely on labeled outcomes. Instead, it identifies patterns, similarities, and groupings within your sales data to reveal hidden trends. One of the most common unsupervised learning techniques is clustering. Clustering groups products, locations, or customers based on similarities in sales behavior. For example, products with similar demand patterns or seasonal trends can be grouped together, helping operators tailor stock and promotions efficiently. Understanding customer segments is another application. By analyzing purchasing patterns, unsupervised learning can reveal distinct groups of buyers with specific preferences. These insights allow operators to adjust product selections, pricing, and marketing strategies to better match customer needs. Dimensionality reduction is also useful in vending data analysis. Techniques like principal component analysis, PCA, simplify complex datasets by highlighting the most important variables. This makes it easier to interpret trends, detect anomalies, and focus on the factors that drive demand. Applying clustering and pattern recognition helps optimize product placement and inventory management. For instance, identifying products that tend to be purchased together can guide bundling strategies or machine layout decisions. These insights enhance both customer satisfaction and sales performance. By the end of this module, you will understand how unsupervised learning uncovers hidden patterns in vending data. Leveraging these insights allows operators to make informed decisions, improve product offerings, and anticipate customer needs, setting the stage for more accurate demand forecasting in future modules. Module 7, Time Series Analysis and Seasonal Trend Prediction. In this module, we will focus on time series analysis and its importance in predicting product demand for vending operations. Time series analysis examines data points collected over time to identify patterns, trends, and seasonal fluctuations that impact sales, helping operators understand how demand changes in different scenarios. Understanding seasonality is a key aspect of time series analysis. Many vending products experience demand changes depending on the time of day of the week, or season. Recognizing these patterns helps operators stock products appropriately, plan promotions, and reduce the risk of shortages or overstocking. Trend analysis is another critical factor. Beyond seasonal fluctuations, long-term trends, such as rising demand for a new product category or shifting consumer preferences, can influence stocking decisions. Time series models help detect these trends early, enabling proactive adjustments to inventory and marketing strategies. We will explore common forecasting techniques, such as moving averages, exponential smoothing, and ARIMA models. These methods analyze historical sales data to make predictions about future demand, helping operators make data-driven decisions rather than relying on intuition or incomplete information. Visualizing time series data is also important. Charts, graphs, and heat maps can highlight patterns, anomalies, and correlations over time. This makes it easier to interpret trends, monitor performance, and communicate insights to stakeholders, ensuring that inventory and product planning align with real-world demand. By the end of this module, you will understand how to analyze sales data over time, identify seasonal and trend patterns, and apply forecasting methods to improve product demand predictions. Time series analysis equips vending operators with the tools to anticipate customer needs, optimize inventory efficiently, and enhance overall business performance. Module 8, Evaluating and Optimizing Model Performance. In this module, we will focus on evaluating machine learning models and optimizing their performance for predicting product demand in vending operations. Accurate predictions rely not only on building models, but also on assessing how well they perform and making improvements where needed. The first step is understanding performance metrics. Common metrics for regression-based demand forecasting include mean absolute error, MAE, root mean squared error, RMSE, and R squared. These metrics quantify how close the model's predictions are to actual sales, helping operators determine reliability. Validation techniques are also essential. Splitting data into training and testing sets allows models to learn patterns from historical data and then be evaluated on unseen data. Cross-validation can further improve confidence by testing the model across multiple data subsets to ensure stability and accuracy. Overfitting and underfitting are common challenges. Overfitting occurs when a model performs well on training data but poorly on new data, while underfitting happens when the model fails to capture important patterns. This module will cover strategies to prevent these issues, including parameter tuning and feature selection. Optimizing model performance involves iterative refinement. Adjusting algorithm parameters, selecting the most relevant features, and incorporating additional data sources can improve predictive accuracy. Operators can also compare different algorithms to find the best approach for their vending operations. By the end of this module, you will be able to evaluate your models effectively, identify areas for improvement, and implement optimization strategies. This ensures that your predictive models remain accurate, reliable, and capable of guiding inventory and product decisions with confidence. Module 9, Integrating External Data to Enhance Predictions. In this module, we will explore how integrating external data can significantly improve demand predictions for vending operations. External data refers to information outside your internal sales records, such as weather patterns, local events, holidays, and demographic trends, all of which can influence customer behavior. Weather is a key factor that affects product demand. For example, hot drinks may sell more during cold periods while cold beverages become popular in warmer months. Incorporating weather data into your models allows for more accurate predictions and helps ensure inventory aligns with real-world demand fluctuations. Local events and holidays also impact sales. Sports games, concerts, or community gatherings can temporarily increase foot traffic and influence product preferences. By integrating this information, operators can anticipate spikes in demand and plan stock levels accordingly, reducing missed sales opportunities. Demographic data provides additional insights into customer preferences. Understanding age groups, income levels, or lifestyle patterns in different vending locations allows operators to tailor product offerings, promotions, and pricing to match the expected demand of specific customer segments. Data integration involves combining multiple sources into a unified dataset that machine learning models can process effectively. This may include aligning timeframes, normalizing variables, and ensuring consistency across datasets. Proper integration maximizes the predictive power of your models and ensures reliable forecasts. By the end of this module, you will understand how external data can enhance your demand predictions, complement internal sales information, and provide a more holistic view of customer behavior. Integrating these insights empowers vending operators to make smarter stocking decisions, optimize inventory, and improve overall profitability. Module 10, Applying Predictive Insights to Inventory Management and Strategy. In this module, we will focus on applying the predictive insights gained from machine learning to optimize inventory management and vending strategies. Accurate demand forecasts allow operators to make informed decisions about stock levels, product placement, and restocking schedules, ensuring products are available when customers want them. Effective inventory management begins with aligning stock with predicted demand. By analyzing forecasts, operators can prevent overstocking items that sell slowly and avoid shortages of high-demand products. This balance reduces waste, lowers operational costs, and maximizes revenue potential. Predictive insights also inform product assortment decisions. Understanding which items are likely to perform well in specific locations allows operators to tailor their offerings. This can include introducing new products, discontinuing underperforming ones, or adjusting quantities based on historical and predicted demand patterns. Restocking and replenishment strategies benefit from predictive analytics as well. Operators can schedule deliveries based on anticipated demand peaks and troughs, minimizing the need for emergency restocks and ensuring machines are always stocked efficiently. This reduces downtime and increases customer satisfaction. Beyond inventory, predictive insights guide broader business strategies. Operators can use demand forecasts to plan marketing campaigns, promotions, and seasonal offers that align with predicted trends. This proactive approach ensures resources are invested where they are most likely to generate returns. By the end of this module, you will understand how to translate predictive insights into actionable decisions. Applying machine learning forecasts to inventory management and strategy enables vending operators to optimize operations, increase profitability, and maintain a competitive edge in a data-driven market. Conclusion. After completing this course, you now have a clear understanding of how machine learning can improve vending operations by predicting product demand. You've learned both the foundational concepts and practical methods needed to make data-driven decisions that optimize inventory, reduce waste, and increase profitability. Data is at the heart of predictive modeling. From collecting and cleaning sales records to incorporating external information such as weather, events, and customer demographics, you now understand how accurate, relevant data forms the basis for reliable forecasts. Well-prepared data ensures models detect meaningful patterns and generate actionable insights. You also gained skills in exploratory data analysis, supervised and unsupervised learning, and time series forecasting. These techniques allow you to identify trends, seasonal changes, and customer behavior, giving a clear picture of what drives product demand. Applying these methods ensures vending machines are stocked with the right products at the right times. Evaluating and optimizing model performance is equally important. You learned how to measure prediction accuracy, handle overfitting or underfitting, and refine models to maintain reliability. Continuous monitoring ensures forecasts remain accurate as sales trends and customer preferences evolve. Finally, you explored applying predictive insights to inventory and business strategy. Using forecasts to guide restocking schedules, tailor product assortments, and plan promotions enables a proactive approach that maximizes revenue and satisfies customer needs. Predictive analytics empowers you to anticipate demand instead of reacting to it. By mastering these skills, you are prepared to run a data-driven vending operation. Machine learning allows for smarter inventory management, better customer satisfaction, and stronger overall performance. The insights gained from this course will help you make informed decisions, optimize operations, and achieve long-term success in the vending industry.